Now that we've walked through how the algorithm works on an example, let's see if we can write down the more general algorithm. We know we need to start off with some input. The input consists of our grid, a start node. This actually would work with multiple start nodes. You could just put them all on the frontier, and a goal, or you could have multiple goals, but again, we only need one. And then here's our algorithm. We need to initialize our data structures, right? We need to have an empty list of visited paths, and we need to have an empty frontier. I'll note that I'm writing pseudocode. This is not Python, although there might be some things that are slightly Pythonic. So then here's the core part of the algorithm. As long as we're not done and there's a path in the frontier, we can keep looping. So while the frontier is not empty, we want to do the following. First, we want to select and remove an item, a path, from the frontier. So select and remove path from the frontier. Now, in our simple algorithm, we'll just remove the first item from the frontier. More generally, you could actually search the frontier and try and remove the best path, but we've already done a little bit of work by trying to add paths in a reasonable order to the frontier. Now, given the path we've just removed, if we've already reached the goal, then we're done. So if path reaches goal, then we're done. And we can just return the path. So the algorithm will end, and we are successful. Otherwise, we want to grow our path by its neighbors and add those to the frontier. So what we can say is for each neighbor, add those neighbors onto the path. So add neighbor to path to make a new path. And I'll say only do this if it wouldn't result in a repeat. So there's different ways we can write this. We'll just say if new path not a repeat. And what that means is the new path isn't on the visited list, it's not on the frontier, and the neighbor wasn't on the path in the first place. So when you coded this, you would actually probably do the if statement before you did the adding. Or you might anyway. So if the new path is not a repeat, then add new path to the frontier. And that's the core of our algorithm. At the end of this, we'll say we need to say, well, the current path wasn't successful, so we will add the current path to the visited list. And that really is the whole algorithm. And it's just a matter of managing these data structures and being careful about not adding new paths if you shouldn't be.